In this set of videos, we're going to take a look at Labor Economics Midterm Exam number 2 for fall of 2015. We'll take a look at the answers that I came up with to the questions on the exam. This will be split into several different videos. This first video will be taking a look at the required question, which was question number 1 in section 1. And then there will be subsequent videos for each of the different questions that you may have tackled. So you'll take a look at more than one video as you review the different answers to the exam. I'll encourage you to take a look at all of them, even look at the videos for questions you didn't answer. This will become good preparation for your final exam quantitative section. So in this first section, we took a look at what is essentially a human capital investment problem. And we first identified that we have Justin. He's about to go into an education program. He's thinking about it. His current salary is about $35,000 a year. The program's got an upfront fee. So this fee is going to be a cost at times 0 for the entire expense of the 3-year program. From which there will be 30 students enrolling throughout the country. That becomes important in a few moments as we look at the answers to this. So preparatory to this, Justin intends to quit his job, expects to find part-time employment at $12,000 a year to sustain him. This will be in the 2nd and 3rd years. Like many, Justin is impatient, but he wants to have a return on his investment that he can quantify within a 5-year period of time after completion, and he expects a 15% return. So that 15% return is his R, if you will. And so we're going to be looking at a time frame here that starts at time 0, goes through time periods 1, 2, and 3 during his education experience, and then 5 more time periods, so 4, 5, 6, 7, and 8 for the period beyond the education. So we're going to adjudicate all of the costs and then all of the benefits within an 8-year time frame. Well, you know how much he's making now, but I haven't told you how much he's going to make, and that's important in this scenario, of course. But what I have given you is a labor supply and a labor demand relationship, such that you're able to identify both the wages that Justin would expect to earn after his successful completion of his program, but you're also going to see the number of workers that are supported at that wage, and that ends up becoming fairly important here. So for part A, the first thing we're going to do is identify what kind of income Justin would expect, and we're going to do that by setting the labor supply and labor demand equations equal to one another. We've done this many times, of course. That's going to yield for us a W star of 7,446.8 and an L star of 117.02, which is 117 workers essentially. Recall that in this story that W star is our variable value, but I've indicated that W is monthly wages. So W star is 7,446.8, but we know that that's going to equate to an annual income of $89,361.60. So we've taken the W star times 12 because I've said that it is a monthly wage. Well, his current income is 35. His school income is 12,000. His R is 15,000, and we're going to set this up in a classic present value equation. And you've seen this equation many times. The generalized form is present value is equal to some sum of beta t divided by 1 plus R to the t. So we have a different term that we're going to sum a number of terms over a period of time to get the ultimate present value of this. Or you might think of this, of course, as a net present value, since we're going to endogenize the costs. I noticed when I looked at the answers that the way that I had chosen to answer this, based upon how I interpreted the information, and the way that some of you chose to do it was a little bit different. when you look at your scores, you're going to find I didn't care whether you did it exactly the way that I did or the way that some of you interpreted differently based on this point. I went ahead and set up the form of the equation, which is what I'm asking you for here. Provide a detailed and complete equation representing the decision. You didn't need to solve the equation or even come up with particular values. You just need to give me the form of the equation. And in this case, I went ahead and said, I've interpreted this as a $67,000 cost at time zero. That's the upfront cost, divided by 1.15 or 1 plus r to the t being 0. And then a series of negative $23,000 values for years 1, 2, and 3. Now, some of you chose a 0 value here, or excuse me, chose a negative $35,000 value for period 1. Here's where these values come from. I went ahead and supposed that Justin had been making $35,000. Was now going to make $12,000 a year during this education experience. The difference then is that he's giving up $23,000 of income that he could have otherwise been making. Some of you interpreted the question to read that he wouldn't be making anything in year 1, so you could have appropriately said a negative $35,000 in year 1, and then negative $23,000 in years 2 and 3. I went ahead and calculated this for the purpose of grading the exam, and if you had answered it that way, I was fine with that. If you answered it the way that I have, I was fine with that. Some of you weren't quite sure how to answer this, and so I had some very creative, albeit unfortunately inaccurate answers as well. So when we look beyond year 3, because we have year 0, 1, 2, and 3. We look beyond year 3. We're now in year 4. Now Justin is beyond his education experience. He is earning this additional income. He's now at $89,361.60. And so the amount of income that he's getting because of the investment experience is an additional $54,361.60. This is not the entire $89,000 because he would have had $35,000 regardless of whether or not he'd participated in the education experience. So the values that we put in the numerator of each of these terms are the values that are being experienced as a direct byproduct of the education experience, and not just, and so it's going to take into account what he's already got versus what he could have, and then the difference becomes these values. So this would have been the answer to part A here. And again, you can see that I've given you each of these different terms with the time exponents that are required, etc. And this runs through a time period of 8. So as we go to part B then, I say, okay, what recommendation will you offer, Justin? And I say, give a complete response, including specific time discounted net cost or benefit. And in this case, if you've used the numbers that I came up with on this, then you can go ahead and assign a value for each of these terms just by doing the math. And those values end up being negative $67,000, negative $20,000, negative $17,000, and so on. You can see the values here, which if you then add those up, it becomes a net present value of $304.03, which is just a little bit greater than 0. So I said, accept this. Let's go ahead and recommend that Justin participate in this. If you went ahead and used negative $35,000 for year 1, and then went to negative $23,000 for years 2 and 3, you would have ended up with a value here of, I believe it was negative $10,000 and something, in which you would have said, that's less than 0, reject, don't do this. And again, either one of those would have been valid. So the next part, C, is regardless of the recommendation offered, so without consideration of the recommendation offered here, suppose Justin decided to enroll in the program, has graduated with his 29 classmates, so that means 30 additional workers are presenting themselves for this market and are going to be employed or seeking employment in the market, and assuming that they're all seeking the expected employment, what wage would they receive if each of them finds a job? Well, what you had to do here was think about the labor supply equation. Labor supply was negative 1,000 plus 0.15 W, But now we have 30 new entrants into this market, so the labor supply equation becomes negative 1,000 plus 0.15 W. And we have to think about it from that standpoint. We also can think about it from the standpoint of what that would do to labor demand. So there were 117 workers that would have presented themselves in this market to be employed. Now there's going to be 117 plus 30. So let's go ahead and plug that in as the labor value that's going to be employed. And that then, if we put that into either the supply or the demand equation, that then can go ahead and change the W or the W prime that comes from this. So I've gone ahead and used the labor demand equation. You could have just as easily used the labor supply equation. And I've said, okay, there were 117, now there's 117 plus 30. That becomes the number of workers. I then have that substituted for L in the labor equation. And then I've said that that value, 147.02, is equal to 2,500 minus 0.3 W, and I've solved for W, in which case I've ended up with a W being equal to 7,353.06, which is less than he would have expected. Now it's $88,236.72 in a wage that they could expect to get if all of them presented themselves and if all of them got jobs, which is less than the $89,316 Justin has expected. So then we have to think about, if in fact this income is going to be less than was originally anticipated, does it change the recommendation that we might have made? And here in part D, that's what we're looking at. So I've gone ahead and recreated my original equation that I had in part A, and I've used, again, negative 67,000. That hasn't changed, and the negative 23, negative 23, negative 23, or in some cases, some of you had negative 35, negative 23, negative 23. And then I use a positive 53,236, which is different, of course, than we used initially. Recall that initially we used 54,361 because it was based on a higher income, supposed. Now we've got a lower income that we're having to realize may actually be their experience when all of these people, 30 people, hit a very thin job market. 117 people in a job market nationwide is a very small job market. And based on the assumption that they all enter into that market and they all get jobs, which means that this market now has cleared, then even at my numbers, we ended up we went from a barely positive outcome of $300 and some to now a certainly negative outcome of negative $2,175. For those of you that had used a negative 35,000 in your first year term, then you would have gone from negative 10,000 and some change to yet further negative. I think it was almost negative 13,000. So since it decreases what we're expecting here, now my recommendation would change. And I would recommend the Justin not return. If that kind of assessment had been done, let's be honest with each other, that kind of assessment is rarely done. So finally, I ask you to take a look at the, I think this is finally, there might be more. I ask you to take a look at the labor demand elasticity on this. And we know that the original wage of W1 was 7,446.8. And that was related to an L1 of 117.02. We then know that if we have a change in this wage, that change is going to give us a W2 of 7,353.06. And it's going to be the result of the L2 having risen to 147.02. So we're going to subject this to our elasticity equation of percent change in labor divided by percent change in wage, which is L2 minus L1 divided by L1, and all of that divided by W2 minus W1 divided by W1. So I go ahead and motivate the equation here. I put in the values in this equation, and I end up seeing that we have a negative elasticity, which I expected because this is a labor demand elasticity. I expect a negative value, and it's an own wage elasticity, so it is negative 20.366. Well, anything above a negative 1, or above an absolute value of negative 1, is elastic, and here at negative 20, this then is very elastic. So my final part of this was, did this surprise you? Was there anything unusual about this? Well, to me, what was a little surprising, if this had been real, and of course it's not, but had it been real, I would have been a little bit surprised that we would have had such a high elasticity for a function, a labor function, that obviously is relatively highly skilled. And we know it's highly skilled for two reasons. One is that we've gone ahead and required additional education to get to it, but also it pays almost $90,000 a year. And I don't know about you, but I think that to earn $90,000 a year, one must be a relatively highly skilled worker. We typically see low elasticities or inelastic levels of elasticity for highly skilled workers because they are less substitutable. We see high elasticities like this, negative 20 or so, when a worker is very substitutable. So that's what I was looking to see if you could determine here.